So I just wanted to show you how this homework is going to look like. So when you hit this setup, what it's going to do is going to create all the agents that we talk about. We have circles, squares, and triangles, and they're of different colors: reds, blacks, greens, and cyan. And so they're just randomly placed. When you hit the layout, we're just doing the spring layout here. So that's what happens because right now we don't have any links, so they're all kind of repelling each other. So what we're going to do is we're going to show a coalition as a fully connected graph, right? So if four nodes are in a coalition, they're going to be fully connected. So they're going to have links between every pair of nodes in that coalition. So what's going to happen is when you hit go, as we stated, each agent is going to make a decision to join the coalition that gives them the highest value, as long as that excess is positive. So if you remember in the homework, we give you the value function, and that is what you use to calculate the value of each possible coalition. So I'm going to hit go once, and there go. So they do all that. We still have layout going on. So and yep, they form the first step of the coalitions. You see, this is a coalition, another one. We see that over here is the plot. The all agents, well, not all agents, 70, weren't that many, 67 agents moved. So even though there's 79, not all of them moved because, it's the way it happens. One goes after the other, so maybe the guy that goes at the end or towards the end didn't feel like moving, didn't see anything better. So this shows you how many moves there are. This shows you how many coalitions. That goes from 79 initially to down to we're at 10, I think. And you can see we have this coalition here of just one guy, and this other one over here, just one guy. So we have two individual coalitions and this triangle here. But you can also see, as the value function states, if you look at it, it basically says that the same shapes like to be together. So we have all triangles here, but also different colors, right? So we have all triangles here, and we have a lot of different colors. So we don't see like all red triangles or all black triangles anywhere, or all red circles. We have circles in this coalition, and this is mostly squares except for that one circle there. So we can hit go again, and they'll do it all over again. And you can see the number of collision drops down a little bit. The number of moves, this is how many agents change coalition. So we see now about 14 agents change coalitions that last time. So there were 14 agents that were unhappy in the current coalition and changed coalitions. And down here, by the way, I forgot about this one. Down here is the histogram of the sizes of the coalition. So there's 8 coalitions of size 4 right now. So that means 8 coalitions with 4 agents. Is that right? I think it's no. There's 4. So it's the other way around. There's 4 coalitions with 8 agents. The other way around. The x-axis is the size. The y-axis is the number, of course, because it's a histogram. So that shows you, gives you another view of what you're seeing over here anyway. And so as you hit go, the number of moves should go down and down and down, and there it went down to 0. It doesn't always go so fast. Sometimes it goes up a little bit and down, and then it goes down to 0. So far, every time I've done it, it always goes to 0. So that means we have a one stable solution. Now this is not a solution that's in the core. So all we're saying is that in this solution here, no one agent wants to leave his current coalition and join another one, or basically gets a higher value, or there's an excess in the new coalition, has a higher value than his current coalition. So that's not true for any one agent, but it could be true for pairs of agents, or triples, or sets of 4 or 5 or 6 or whatever. So we're not saying that. That's if you could say that, then we could say that this is a solution that's in the core, but we haven't checked that. And you can see, hopefully you can see that that would be really hard to check, computationally speaking. It would take a very long time with 80 or 79 agents.